Hi guys, I'm Roshan from here. And guys, today I'm going to talk about the first second of the entire world. So, without further ado, let's get started. So, basically, at the start of the universe, approximately 14 billion years ago, space, matter, and energy were all compressed into a trillionth of a dot. Yes, you heard that right, a trillionth of a dot. This energy was so complex that the temperature was so hot and all the forces had to be unified. This is best described by our very own Einstein's theory of general relativity. So, 14 billion years, that's too long a time. So, we have divided it into segments called era. An era is a really long period of time. So, the first era is known as the Planck era. It's a common name for astronomers. So, the first era is known as the Planck era, okay? And it lasted for 10 to 43 zeros, which is 1/10 million trillionths of a second. Yes, not even a second. 1 million trillionths of a second. That's too small. So, this Planck era was the starting of our universe. And don't forget yet, we have not yet reached a second. So, the Planck era is named after German physicist Max Planck. So, Max Planck gave the first detailed insight about quantum mechanics or quantized objects which are really small, and is also known as the father of quantum. So it's named after Max Planck. So as I told you, all the energy was compressed into the tiny dot. Now, that dot was too hot, and since it was hot, it had no other chance but only to expand into great space around it. The cosmos had now evolved, and this event is known as the Big Bang. But hold on, you're not even reached yet. So this Big Bang, okay, we had only one element called photons in the beginning. They were light. So photons, okay, as I told you, they were light. Photons. So basically photons are molecules, particles that shine off light. And now the four forces, okay, the four forces which had once unified in the beginning had now started to split as the temperature started to drop, as there was no other way. So, as the temperature dropped, as I told you, they had to split. So, for example, if we take electric energy, they had to split into electroweak and strong. subnuclear. And electron weak have to further split into various categories. And this splitting happened, as I told you, because of the temperature drop. And by now, only 1/1,000,000th of a second has passed. So after 1/1,000,000th of a second has passed, we have come to a new age. But a new age also didn't last for a second, as the Planck era. So remember we talked about photons before? These photons in the universe started doing matter to antimatter stuff. Yes, this is actual scientific terms. Antimatter is not science fiction. And this event is also described by our beloved Einstein in his most famous theory, E is equal to mc square. In this we take a part of C, because C is photon, because C is light and photons are also light. So basically the C square in E equals to mc square denotes light, which is squared. So C equals the speed of light squared. So this light squared, okay, or the speed of light squared, tells us all the energy that has been available to us. Okay, so the C squared tells all the energy that has been available to us. So C squared can be also written as speed of light squared. So now, we have talked about photons before, but there are also other molecules such as leptons and bosons and electrons and neutrons. So let's go further into them. So, photons are a part of the bosons family. Leptons, which are also another type of molecules. So there was also lepton error, which you didn't know. So photons are bosons and leptons are part of the electron family. And many people have been wondering about quarks. Now, if you are wondering about quarks, this is a likely question. Roshan, what are quarks? Which family do they belong to? Quarks belong to no family. Quarks are a family of their own. They are quirky beasts, and the more you try to pull them apart, it's sort of a subnuclear rubber band which is trying to contract them together. So, quarks. So let's denote quarks as a Q. So if there are two quarks together and if you are able to try to pull them apart, there's some sort of subnuclear elastic band. Okay? This kind of subnuclear rubber band which is contracting them together. And the more you pull them apart, okay, so the more you pull them apart, they become stronger and they grow in number as well. If there are two quarks here and you pull them apart, they become stronger, and the E equals to mc square method also applies here. And now they double up in number. And by now you're wondering, Roshan, is it a second yet? Has an hour passed? Or maybe it's a day or year? You all are wrong. Not even a second has passed. Again, only 1/1,000,000th of a second has passed. Now, we come to a new type of molecule. They're not photons, they're not bosons or any other we have studied before. They are called hadrons. Hadrons or hadrons has come from the Greek word hadros, which means thick. So that's hadron's quality. So these hadrons or hadrons, I'll call them hadrons. So these hadrons do not implement the rule of E equals to mc squared. So they're a bit confusing. But to make things straight, hadrons are like proton. Hadrons also do hadron and antihadron stuff as photons who do matter and antimatter stuff. So let's go deep into hadrons and not photons. As I told you before, hadrons do hadron and antihadron stuff. So we again have hadron and antihadron stuff. So this is the start of a new era called the hadrons era. But by now, the temperature has gone down almost about 3000 Kelvin, which is actually a lot. So the temperature has gone about 3000 Kelvin and the entire universe is start to cool. And since we have this kind of scenario, the photons increase, and now we have the scenario, let there be light. So photons increase and we have the scenario, let there be light. And this, guys, is the first second of our universe. Yes, you're right. Finally, 1 second has passed since the Big Bang. Hope you like this video and I hope you tune in next time for some more amazing science facts. Until then, it's me, Roshan Kanna, signing off. And I would like to convey my thanks to Neil deGrasse Tyson, a beloved astrophysicist whose books has given me a huge and immense source of information.